Hi, my name is Alexander. In this video, we will convert Angular project, Angular 18 and NGRX state management to React project with the same UI and business logic, and discuss the differences between Angular and React projects. In React projects, we will not use global state. We will use it in the next video. In the video description, you can find a GitHub link to the code repositories. To save you time, I have converted already the client-side application of Angular 18 and NGRX state management project to React application, React 19 store. The server-side application is the same for both projects. Therefore, we use the server-side application of the project, Angular 18 and NGRX state management. The difference exists only in client applications, where to make HTTP requests, Angular application uses HTTP client service, and React application uses promise-based Axios HTTP client. Let's demonstrate that both applications provide the same UI and business logic. After that, we will look at the conversion process. Click the buttons Products, Computers, Cars, Cafeteria. Both projects provide the same results. Check root operations in React project. Get product, add product, update product, delete product. Empty form. Everything works as expected. We created React 19 store project with the same UI and business logic as we implemented in Angular project, Angular 18 and NGRX state management, except for the global state management in React project. In React project, the button click event for the clear state button we will implement in the next video. Let's create React 19 store project from the scratch based on the Angular project, Angular 18 and NGRX state management. Folder cwork React projects. Go to projects directory. Check that application works. It works. To create a drop-down list in the form, we have to install React Select package. To communicate with SQL Server in React, we will use Axios library. Open application in Visual Studio 2022. Add Services folder and Fetch Helper folder. Create Fetch Service JavaScript file with Axios HTTP requests. Other methods that do not contain HTTP request we put into the file Fetch Helper. The server-side project remains the same for both projects. Therefore, we will use the same HTTP requests from the client side in each project. The only difference is the syntax required for HTTP requests using HTTP client service in Angular project and for HTTP requests using Axios. Angular uses TypeScript and TypeScript uses static typing. Therefore, in Angular, we can create a typed request to specify the desired type next to the method name. This enables type assertion at compile time, improving code structure and development speed. In both applications, we created the same HTTP requests with the same number of parameters, which we put in HTTP headers or in HTTP params object. In Angular application, we use 4 components: cafeteria, cars, computers, products. In the early days, React primarily relied on the class-based components, but after introduction of React hooks in React 16.8, the transition to functional components began. In React, we can create 4 functional components, but we created only 2, products and department, under the Superstore folder. Because the components cafeteria, cars, computers are used to display items from appropriate department, we can create only one functional component which we will use to display items from different departments. The components in React use JSX syntax extension for JavaScript to describe what the UI should look like. It combines HTML-like syntax with the power of JavaScript. It needs to be transformed into regular JavaScript code that browsers can execute. This transformation is typically done by tools like Babel. Up to the React version 17, it requires import React from React at the top of our component file. In React 17 and later versions, a new JSX transform was introduced. With this transform, you no longer need to explicitly import React in files that only use JSX. However, the React object is still implicitly used behind the scenes by the transformed code. In Angular project, we use inheritance. The components use the same parent class product base, where we put the methods common for the components, like clean up text area to clean up text in the text area, check connection to check connection with the server and print the message cannot establish connection to the server in the text area when connection cannot be established. Display product list to display product list in components table. HTTP get product list to display all products from SQL Server database. Functional components in React do not support inheritance. Therefore, the functions common for the components we put in the separate files and use import these functions into components. For example, clean up text area, show status, get products, and so on. To create the components in React project, I use the HTML code from components in Angular project, which I put under the return statement. We can see that HTML code in React component is almost the same as in Angular component. React uses different syntax. HTML attributes in JSX are camel case, like onClick, class name. React functions and values in HTML are enclosed in curly brackets. When function requires parameters in HTML, we can wrap function call inside anonymous function. We put functions into separate files, fetchHelper.js and fetchService.js, and import required functions into components. In Angular project, we use two-way data binding to synchronize data between the components model and the view. When the model changes, the view updates, and vice versa. React doesn't support two-way data binding, therefore to synchronize products properties between input fields and products object, we use React state management. In this pattern, the product object is tied to a state variable product. The input field values contain the properties of the product object. When the input changes, the state is updated, and React re-renders the component reflecting the new values in the input fields. The onChange event handler is crucial for capturing user input. This handler is triggered whenever the value of the input field changes. Inside the handler, we update the state object and consequently the input fields. I copied all required functions like display product list, check connection, clean up text area, show status, and others from Angular project to React project as is. I only changed the function signatures and removed the TypeScript syntax like types, access modifiers, etc. Department component is used to display products from the departments: cafeteria, computers, cars. Add routes for navigation between pages. To use router in React, install React Router DOM library. We edit layout and no page components under the Superstore folder. In layout component, we use link to navigate the products component and buttons clicks to navigate to department component. In app.js, we have to use React Router to route to pages based on URL. We wrap our content first with browser router. Then we define our routes. An application can have multiple routes. Our project only uses one. Routes can be nested. The first route had a path / and renders the layout component. The nested routers inherit and add to the parent route. So the products path is combined with the parent and becomes / products. Setting the path to asterisk will act as a catch-all for any undefined URLs. We use it to load no page component to show the message 404 page not found. The three paths, computers, cars, cafeteria, are used to load department component. Department component analyzes the current URL to get the department's name and set the variables. Type ID, which is used to select products from the SQL Server database based on the department type. Tab, this is a placeholder for the table where the product list will be displayed. In the current implementation, theoretically, we can omit this parameter and use hard-coded value for all components, but it is not a good idea because with the tab parameter, in the future we can display all tables of components together in one page. Department, this variable is used to display the name of the department on the page. After loading department component, or by pressing Get Products button, the Get Products function starts with parameters and displays product list of the selected department. When client application cannot establish a connection to the server, the component cannot display product list. Therefore, we can use button Get Products when connection is restored. In Angular, to display products after loading component, we used a lifecycle hook after viewing it. That is invoked immediately after Angular has completed initialization of a component's view. It is invoked only once, when the view is instantiated. In React, for the same purpose, we use useEffect hook. The useEffect hook in React is used to perform side effects in functional components. By default, effects run after every render. However, you can control when an effect runs using the dependency array argument. To make useEffect hook run only once after the initial render, you should pass an empty array as a second argument to the hook. This tells React that the effect doesn't depend on any values from the component's scope, and therefore it should only run once after the initial render. In a department component, we use state management with a state as a Boolean variable loading, which is set to false in useEffect hook when component is fully loaded. After that, we can call getProducts function to load product list. Copy CSS classes which we created in Angular application to app.css file in React application. Start server-side application and React application. Press Products link. We have a message server is down. Open console. We see the message access to fetch at server URL from origin client URL has been blocked by course policy. Cross-origin resource sharing course is HTTP header-based mechanism that allows a server to indicate any origins, domain, scheme, or port other than its own from which the browser should permit loading resources. To resolve the course issue, we need to tell the browser that we allow the request from our client URL, HTTP localhost 3000. Stop server-side application. Open program.cs file. Currently, in the course policy, we allow the requests from the URL localhost with a port 4200. This port is commonly used as a default for the development servers, particularly for the applications built with frameworks like Angular. Let's add the URL of our current React application, localhost 3000. This URL is commonly used when we start a React application using tools like Create React App or similar development setups. Start server-side application. Start React application. Click Products. We received the product list. Check department buttons to get product list by department. Computers, cars, cafeteria. Check root operations. Open SQL Server. Update product. Product updated in SQL Server database and in the components table. Add product. Product added to SQL Server database and to the components table. Delete product. Product deleted from the SQL Server database and from the components table. Check notifications and error messages. Get product which doesn't exist. Notification message, no data found. Update product that doesn't exist. Error, record with the product ID 141 doesn't exist. Add product that already exists in database. Error, cannot insert the record with ID 14, violation of primary key constraint. Check how our application catches undefined URLs. We received HTTP status code 404, page not found. To continue, click the link of any button on the form. Check the notifications when the server is down. Stop server-side application. Check root operations. Server is down. Click department buttons. In all the cases, the server is down. Our React application works as expected. Let's recall the main points of converting an Angular project to a React project. Function signatures. Angular uses TypeScript function signature with types and access modifiers. React uses JavaScript signature without types or access modifiers. Angular uses two-way data binding to synchronize data between the component's model and the view. React uses React State Management to synchronize data between view and state. Angular components use inheritance, which allows child components to access the properties and methods of the parent component. React functional components use utility functions to import reusable functions into components from separate JavaScript files. In Angular, to execute the method only once after Angular has completed initialization of a component's view, we use lifecycle hook ng after view init. In React, for the same purpose, we use useEffect hook with an empty dependency array. To make HTTP requests to backend services, in Angular, we use HTTP client service. In React, we use Axios HTTP client. Angular uses an HTML template to control what is displayed in the DOM. React uses JSX, a syntax extension to JavaScript that allows to write HTML-like code within JavaScript files. HTML properties, events, functions have different syntax in Angular and React. In this video, we converted Angular project to a React project with the same user interface and business logic. That's all what I wanted to show you in this video. In the next video, we will use React Global State Management to handle data that needs to be accessed and modified by multiple components across React application. This is in contrast to local state, which we used in a current video and which is confined to a single component. If you're enjoying this content and would like to see more and support my channel, please feel free to like this video and hit the subscribe button. Thank you for watching, have a good day, and bye.